Pluto made them come all alongside. Pluto's circle crosses that of a few other planets. Pluto, the hard little planet on the outside scopes of our close-by planet organization, is working up electricity on Earth of cosmology. Ongoing reviews suggest a plausible and joy with Neptune raising issues among researchers and place fanatics. Key figures like Neil deGrasse Tyson and Mitaku have sounded cautions about the ramifications of this infinite occasion. However, how did Pluto develop to become on a crash path with its adjacent planet? And what should this heavenly conflict propose for life on this planet? Be a part of us as we disentangle how something huge simply slammed into Neptune and how researchers had been left burdened through this enormous irregularity. Pluto, once hailed as a plain planet, went through a change in its reputation, being renamed as a Bantam planet due to its unconventional circle. Notwithstanding this downgrade, Pluto sincerely spellbinds and pursues the cosmic nearby region. Later forecasts from esteemed researchers like Neil deGrasse Tyson and Mitaku have raised issues approximately Pluto's route likely converging with Neptune, indicating and drawing near string of outcomes between the two divine bodies that could have crucial repercussions for Earth. Pluto's excursion around the Sun stands aside due to its pinnacle-notch attributes inside our nearby BIP planet organization. Its circle is mainly tremendous, crossing a beautiful amount of astronomical units. Considering that its revelation in 1930, Pluto has yet to finish a full unrest across the solar. Adding to its character is the profoundly stretched nation of its circle, a departure from the more roundabout approaches followed through the big planets. Furthermore, Pluto's circle strays by 17 degrees from the ecliptic aircraft, giving its way a more intense grade contrasted with certainly one of a TYP planet. The combination of Pluto's nature and its curved circle provides layers of intricacy to its orbit. One prominent angle is its occasional convergence with Neptune's circle. For about 20 years all through each circle, Pluto ventures nearer to the Sun than Neptune, resisting assumptions in view of their separate situations within the nearby planet institution. Digging further into Pluto's circle, it's far captivating to take notice that it is anything but an extraordinary circle, but as an opportunity a lengthened circle reminiscent of more of an oval shape. This notable circle results in a vital sort in Pluto separation from the solar. Throughout its tour at its nearest method, Pluto goes indoors round 30 astronomical devices of the Sun. While at its farthest point, it includes more than 49 times the space of Neptune from the solar. Further, Pluto's circle is leaned at a point relative to the circles of the tremendous planets in our nearby planet employer. This tendency now not simply provides to the intricacy of its circle but also assumes a crucial component in its collaborations with special heavenly bodies, i.e. especially Neptune. When Pluto encounters Neptune, their gravitational influences adjust their instructions over time. The many-sided dance among Pluto and Neptune highlights the dynamic nature of our nearby planet group. Even as Pluto changed into once appeared as a solitary drifter inside the outer reaches, its nearby encounters with Neptune's spotlight the interconnectedness of heavenly bodies, each utilizing gravitational forces that shape the paths of others. In later years, advancements in observational technology have assisted cosmologists in tuning Pluto's actions with wonderful accuracy. This has brought about a deeper comprehension of its circle and its probably ramifications for the stability of the outer nearby BIP planet institution. Even as the chance of a direct impact among Pluto and Neptune remains low, the possibility cannot be absolutely discounted, prompting endured tracking and test via the astronomical community. No matter its modest length and a way-off region, Pluto proceeds to command hobby among researchers and fanatics alike. The query emerges: why hasn't there been an accident amongst Pluto and Neptune? The reaction lies within the pull of gravity from wonderful planets. Stargazers began focusing on Pluto's way, now not lengthy after tracking down it, and its direction baffled them. Differing to most planets that stick near comparable planes as they circle the solar called the ecliptic aircraft, Pluto stands apart with its treasured truth aspect and oval-shaped circle. The mystery elevated when they understood Pluto's way crosses Neptune. No matter these intricacies, Pluto's circle stays sturdy, showing the complicated mechanics of region. Learning how three divine bodies circulate and collaborate gravitationally, like Pluto, Neptune, and the Sun, is a large assignment. It's like attempting to foresee wherein they will skip based totally on in which they start and how they pull on each other. For PL, this venture well-known shows how its manner, Neptune's manner, and the sun's all artwork like a simulation. Libration and the VSOP wavering these help researchers with settling this big riddle. A simulation is important for retaining planets in their circles. While Pluto crosses Neptune's manner, it's at least 90 degrees away, keeping them from crashing. Libration guarantees that even as Pluto strategies Neptune or other massive planets, it's far nicely over their way, reducing the hazard of a crash. The VSOP wavering, named after researchers VAV Zappel, Steve, and Sapling, figures out why Pluto's circle seems exquisite but remains every day over the longer term. No matter the confusion in space, some styles and guidelines maintain things in request. These recommendations maintain Pluto's circle solid, stalling crashes with Neptune or adjustments in its manner. The possibility of orbital mayhem explains how a heavenly body's manner is extraordinarily sensitive to wherein it starts. It is very lots represented by Pluto. Indeed, even little adjustments in its state of affairs or velocity can ruin its circle over a long time. Researchers use PC simulations to type out how Pluto actions in area. These simulations use extravagant math to duplicate how Pluto friends with exceptional area stuff like Neptune. By tweaking these, researchers can apprehend how small modifications can exchange Pluto's manner. In the final part of the 190s, these reenactments track down something fascinating approximately Pluto's circle. In spite of the fact that there are subjects that need to make it stable, Pluto's circle can nonetheless be eccentric. A minuscule distinction in wherein Pluto starts off advanced or how brief it's going can roll out large improvements over excessive years. However, in spite of this disorder, Pluto's circle stays strong for exceptional long times, like billions of years. This suggests that, in spite of the fact that Pluto appears out of manage, its excursion across the solar follows quite some of some kinds or any other. Searching beforehand to what's going to occur with planets like Pluto that have awkward circles is difficult. These frameworks are so capricious that it's miles hard to take into account what's going to occur over the lengthy haul. Recreations help us discover about what may additionally want to occur, but they likewise display us that we cannot foresee all that simply. This records assist us in seeing better how our solar framework works. Pluto's circle indicates us how circles that look like flimsy can modify because of gravity and how things bypass in region. Persevering with to look at is big, moreover that specialize in these matters, so we will apprehend where we inform within the universe. On the thing when we inspect vicinity, we decide out that subjects can be eccentric, and Pluto's circle is an exceptional instance of that flightiness. Pluto's circle isn't always like those of various planets. It is far more oval-shaped. Because of this it's no longer a perfect circle. Right here and there it even gets in the direction of the solar than Neptune does. This can make things exciting because Neptune is also obtainable cruising along its way. There is a little possibility that Pluto and Neptune may additionally want to find one every other quicker or later. Notwithstanding its uncommon circle, Pluto figures out the manner to stay far away from Neptune most of the time. This is due to something mentioned as gravitational forces. Gravity resembles an undetectable strength that draws matters in the path of each other. So even though Pluto and Neptune need to appear as though they're on a collision path, their circles are painstakingly arranged actions directed with the aid of the draw of gravity. Pluto's circle instructs us that vicinity is loaded with shocks. What seems to be tumultuous from the get-go appearance can be a sensitive equilibrium of forces. By specializing in Pluto's circle, researchers gain insight into the mind-boggling mechanics of our planetary agency. This ongoing observation and research are fundamental for extending our facts of the universe and our location in it. Believe if Pluto and Neptune impacted, it might be an inestimable occasion, sending wonder waves through our comprehension of the nearby planet corporation. Even as we have gained ground in status area, what's taking place indicates that we genuinely have a long way to go. Focusing on what large planets advocate for Pluto's manner gives us properly sized quantities of statistics about how our entire nearby planet group works. It indicates us that in which each planet is and the way its actions can exchange the strategies of various matters in the area. Notwithstanding the reality that area is convoluted, some top researchers are forced that Pluto should collide with Neptune. This makes them can't assist, considering why this will show up. Regardless of the fact that it seems now not likely, Neil deGrasse Tyson, a renowned location researcher, makes them hobby thoughts regarding Pluto. He imagines that renaming Pluto as a bantam planet, not a high one like Earth, is a diploma forward. He accepts we're usually learning new things about how matter skip in space. Tyson sees Pluto's uncommon way as a signal that there may be nonetheless a ton we do not understand. He feels that the myriads of area are so captivating. He likewise is conscious that significant activity sports in vicinity, like Pluto's renaming, get people intrigued in area era. Tyson hopes to help human beings to preserve near the cool and at times unusual topics approximately resident space functions. He believes it's far important to talk approximately how area mechanics can wonder us. Tyson works with other researchers to caution humans approximately the capacity risks of Pluto's weird path. Within the wake of that specialize in Pluto, the truth that it is able to collide with Neptune one day makes him targeted. He says this may reason great troubles for our entire planetary gadget. An accident between Pluto and Neptune can be an unusual and important event. It would release a variety of electricity and ought to damage apart Pluto pieces. Debris from the collision ought to fly around area and hit other planets and moons. Neptune may also revel in the impact and alternate the way it actions. Renowned theoretical physicist Makaku, acknowledged for his contribution to thread idea and technological know-how communication, offered an interesting perspective on area exploration. He believes that understanding the destiny of space travel and the connection between celestial mechanics and theoretical physics can be achieved from that specialize in peculiarities like Pluto's circle. Kaku considers Pluto's circle to be a window into the future of space exploration. By way of grasping the multifaceted gravitational interactions and orbital dynamics of heavenly bodies like Pluto, we will improve future area missions. Helping with safer navigation through the solar system, predicting potential dangers, and making plans missions to remote corners of our cosmic neighborhood is essential. Kaku emphasizes that lessons discovered from Pluto's circle can be implemented to exploring different heavenly bodies. Offering a roadmap for exploring distant worlds, he regularly highlights the deep connection among celestial mechanics and theoretical physics, stressing that the interactions of planet inclusive of the gravitational dance between Pluto and Neptune are rooted in essential concepts of physics. Kaku's paintings in theoretical physics, especially string concept, goals to unravel these standards at their center. He suggests that focusing on the complexities of celestial mechanics like Pluto's circle can provide insights into the underlying legal guidelines of the universe. Just like Tyson, Kaku has additionally pondered the potential collision of celestial bodies and tied it to his theories about the universe. A collision between Pluto and Neptune, even as sizable in astronomy, could provide a unique observational opportunity, potentially contributing to our expertise of string concept and different theoretical physics areas. Such an effect could create excessive situations of energy and gravity, shedding light on the behavior of fundamental particles and forces below intense conditions. A key consideration in string concept, moreover, the gravitational waves produced via such an effect ought to offer valuable statistics for trying out predictions of string idea concerning gravity in spacetime. While the direct impact on Earth might be insignificant due to our distance from the outer planets, the medical implications may be profound. Understanding events like this ought to increase our information of the essential nature of the universe as described through string principle and different theoretical physics areas. Pluto's specific characteristics inspired via the gravitational force of neighboring planets, especially Neptune, highlight the complex and dynamic nature of area. Yet, the universe holds many mysteries, and the three-body trouble is simply one in all of them. Researchers anticipate different potential collisions, highlighting the continuing quest for knowledge and exploration in the substantial universe. Even though it's distinctly not going, there may be still a small opportunity of planets taking pictures each other in area. This could show up because a planet's direction is influenced by various factors like gravity from other planets, which researchers name the three-frame problem. In locations just like the TRAPPIST-1 system, where there are 7 Earth-sized planets, the gravitational forces create a kind of rhythm in how the planets circulate, referred to as orbital resonances. Over time, these paths could make a planet's route less stable and will lead to collisions. Even though systems like TRAPPIST-1 are teeming with planets, crashes are not happening proper now. Researchers preserve an eye on these structures to apprehend how planets affect each other's paths, mainly once they get near. This enables us to understand how planets circulate in space and what factors influence their long-term stability. The complexities of planetary interactions, such as those between Pluto and Neptune, underscore the intricate dance of gravitational forces shaping our celestial neighborhood. As we delve deeper into understanding these dynamics, scientists aim to uncover fundamental principles governing the cosmos. Pluto's orbit, with its peculiarities and occasional proximity to Neptune's path, serves as a case study in celestial mechanics. It reveals how seemingly irregular orbits can be stabilized over time through gravitational interactions. The simulation models developed by researchers provide valuable insights into how such interactions evolve and influence the trajectories of celestial bodies. Moreover, ongoing advancements in observational techniques continue to refine our understanding of Pluto's orbit and its implications for the broader solar system. By tracking subtle changes and anomalies in Pluto's path, astronomers can predict its future movements with increasing accuracy. This knowledge is crucial for assessing potential risks posed by Pluto's orbit, including the unlikely but possible scenario of a collision with Neptune. The study of Pluto's orbit extends beyond mere astronomical curiosity. It holds implications for our understanding of planetary formation and evolution. By examining the interactions between Pluto, Neptune, and other planets, scientists can reconstruct the dynamic history of our solar system. This historical perspective helps us grasp the processes that have shaped the planet's orbits and their current configurations. Looking ahead, the exploration of Pluto's orbit offers a gateway to unraveling broader cosmic mysteries. It prompts us to reconsider our assumptions about the stability and predictability of planetary orbits, challenging us to refine our models and theories. The ongoing dialogue among astronomers and physicists enriches our knowledge of celestial mechanics and theoretical physics, paving the way for future discoveries in space exploration. In conclusion, Pluto's orbit serves as a captivating example of the intricate interplay between gravitational forces and planetary motions. Its irregularities and interactions with Neptune offer valuable insights into the broader dynamics of our solar system. By studying Pluto's orbit, scientists deepen their understanding of how planets move and evolve in space, advancing our knowledge of the cosmos and our place within it.